There are essentially two important points to keep in mind during vertical multiplication of two-digit numbers. The first is the importance of place value, which we just covered. And as stated, the significance of place value accounts for what otherwise might be seen as an arbitrary shifting of some of these numbers found during the problem one place to the left. The second important point to keep in mind is the reasoning behind the process of carrying, which may initially seem odd to students. However, the reality is that it's only one method to employ that may simplify the final addition in the problem and doesn't necessarily have to be used. In order to more fully illustrate what actually goes on during the process of carrying, it may be useful to demonstrate how a problem would look without using carrying. This will also illustrate the fundamental concepts at play using place value. First, it's important to reinforce to students, as stated, that carrying is simply a useful tool that may simplify their multiplication process when they get to the point of carrying out addition. Therefore, the process of carrying and these floating numbers is neither arbitrary nor based in superstition. If students choose to carry, they'll encounter it when the product of two numbers is greater than 9. In this case, we'll compose the value found into a number of tens or hundreds along with the ones. For instance, if multiplying two digits in the ones column in this first example, 45 times 56, when multiplying the 5 and the 6, the product is 30, which obviously has a value greater than 9. Therefore, we compose this number not into 30 ones, but into 0 ones and 3 tens, writing the 0 and carrying the 3, which represents the 3 tens. Thus, in the next part of the problem, when 6 times 4 is multiplied, which is actually 6 times 40, yielding 240, the 3 carried tens are added, yielding the final product of 270, which is written here in the process used with carrying. However, as stated, this is not necessary and merely just a convention. One can just as easily line up all the individual products, using correct place value, of course, and the answer should come out the same. Therefore, there are many ways to do this process correctly. When we carry, we'll end up adding 270 plus 2,250, as illustrated in previous videos, yielding the final product of 2,520. However, when we choose to carry out this process without carrying, we simply have more products to add. We add the individual products as 6 times 5, 30, 6 times 40, 240, 50 times 5, 250, and 50 times 40, 2,000. Students will have to keep in mind, if they choose to use this method though, the significance of the 4 being a 40, the 5 being a 50, etc. As stated, this will work just as well, just more products to add when you get to the final step. However, it's clear to see that these two methods are equivalent, as 240 plus 30 is clearly 270, and 250 plus 2,000 is 2,250. Therefore, students may choose to use the method that doesn't use carrying if they feel more comfortable adding, obviously carrying being involved here too, than carrying during the actual multiplication. It's still very important to emphasize to students when teaching the method without carrying in these types of problems that place value still comes into play, regardless of having to deal with these carrying floating numbers. For instance, when we multiply 6 times 5 and the answer is 30, we have 3 tens and no ones. Multiplying 6 times 40 and getting 240, it's important to remember that this is composed of 2 200s, 4 tens, and 0 ones. As such, it must be lined up with the appropriate place value already demonstrated by the placement of the 30. Next, when students multiply 50 times 5, getting 250, this likewise must be lined up with the appropriate place value columns, the 2 with the other hundreds, the 5 with the other tens, and the 0 again in the ones column. Finally, in multiplying 40 times 50, getting 2,000, one must shift over again, placing the 2, which represents 2,000s, in the column that represents its place value by itself over here, the 0, so likewise with each individual column. Thus, adding straight down will give the correct product of 2,520. If proper place value is not utilized during this process even without carrying, the answer would obviously be incorrect. This concludes the explanation of the conventional algorithm for carrying out vertical two-digit number multiplication problems, placing an importance and emphasis on place value, as well as the application of the method of carrying.